الله الرحمن الرحيم. Um, Regarding the quiz, if you notice that I attached a summary material with explanations. I send you this file, a PDF file that contain a summarized context, a summary of the material. So this is not PowerPoint and this is not the textbook, but it is something in between where all topics are explained with with a very brief explanation with the simplest English possible, English language. So I hope you benefit from it, inshallah. It's good for you for reading to understand the major concepts of the course. طيب. Uh, Inshallah, I will continue building this file and make it larger and larger until the end of this semester. So you will have a very good handouts about operating system summarized in this file. Slowly, I will try to finalize it for you. طيب, regarding today's class, we will talk about chapter 2, and chapter 2 will cover the major services of operating system, which we already talked about before, and also something about the system calls, where we can have more look into what is a system call. And then there are some topics I think I will not cover here. Okay. طيب. Anyhow, the first thing about the services, the operating system services, we already covered it before, but now they are writing it in a different way from a service point of view. Before we said, last time we said that this is the functions. What do the operating system function? What does it do? So it do many things like the program execution. So when you program the execution, you are running the CPU or the processes manager or management. You do scheduling of jobs or tasks or processes. This is the same thing. I/O operations. It's the same as I/O devices management. File system manipulation is the same as file system management, and so on. So this is the repeating of the same topics, and in addition, we have few different explanation here. But anyhow, uh, we already covered it, so I will skip it to only this overview. This is a view of an operating system services, and so these are the services or the functions that the CPU do or the operating system do. So we call it services because it's a service for the users. We call it functions because it explains what do the operating system do. It's the same thing, right? And the thing I want to focus today is the usage of the system calls. The usage of the system calls. Now, what is exactly a system call and how the user use the system call? It's very simple thing. I will show you in one example. Now, every one of you know how to you're supposed to know how to uh, program in C language. Okay. Now I will write this simple program here. Include stdio.h stdio.h. So if you remember in C language in CS101, when you write this program include stdio.h and then you say okay, print hello world, what is exactly happening when you run the program? Now this program runs hello world. Now suppose you deleted this line. or you make it as a comment, so it's not included. Does it run, or it give you warnings and errors and something like this? So if you click run, then it give you a big warning here. Some other compilers, it will never run. It will give you error and it will never run. But this is a smarter compiler here. So they gave you a warning and they did the job for you. So they included stdio.h because they know that this printf thing, this printf is a function. This name is defined. The details of this instruction, the details of this function is inside stdio.h file. So stdio.h this is a standard input output file. This file, there is a program code inside this file, and inside this file there is one name, printf. So when you write here printf, it is simply executing the instructions under this name. Where are these instructions? Inside stdio.h. This is the simple thing about it. Now, printf will print something on the screen, like hello world here. It's printing on the user screen. It will print hello world. Now, the if I delete this and I put this command write, okay, and I delete include stdio.h. What is write? What is write function? If I run it, it also print hello on your computer. Okay, hello or hello world, whatever. Right? It's also, it is printing hello on your computer. So if we have a command called write that prints on your computer, so why do we need to use printf? Why they created printf for us? The distinguished between printf and printf is a user application, and write is a system call. It's as simple as that. Okay, inside this the operating system, we use in C language a function called write, and this function purpose is to print on the screen. So this directly communicate from operating system to the hardware, this order. But printf does not directly contact with the hardware. Printf is a command or an instruction or a function defined by the user, whoever created the C language, and you use it to print on the screen. So printf is the user program. The user program. Printf is the user program, and write is a system call. So printf use the write function in order to access the hardware. So this is what is happening inside the operating system. So we have multiple system calls. In this course, you also going to learn a list of system calls where you can use it in the lab, inshallah ta'ala, and you have a project to work on it. So this drives us to more understanding about this system calls. Okay, so a system call Usually it is written in C language or C++ language. Okay, and it is a programming interface to the services provided by the OS. Okay, just to make it more clear for you, what does interface mean? Okay, so I want to just skip this here. Okay, now a system call is an interface. It's an interface, يعني it's an intermediate. It's something in the middle. You see, it's here in the middle between this box, which is the services. As you see here, this is the services. These are the services and the user, right? So a programming interface provided by the operating system, typically written in C or C language. Right? Mostly accessed by programs via a higher level application programming interface rather than direct system calls. Usually, you don't use a system call directly, but you use even something uh, easier called application programming interface, an API. So this is all. This is a software. This is another software. Just to simplify as much as you can, how to access the operating system services. It is simplified. So you might find user interfaces. You might find instead of writing system calls here, they write APIs instead of writing system calls. Here, some places you will write, they will say, okay, API. So application uh, programming interface. طيب. Most commonly used APIs are in Windows 32 or Windows generally, and some other also. The APIs are used in Unix, Linux, other operating systems. طيب. We talked about this example last time. Okay, and so I gave you this example about read, and this is another example of a standard API. For example, if you include in C language unistd.h, and then you can have this function called read. If you, I give you an example for write, so also write for printf. Printf read is something like scanf in C language. So you can use this function, read and write, uh, as an interface directly to access a service from the operating system. Right. This is another illustration. Okay. So for another example, open. So this is a user mode application. You run it through the system call interface. You access the kernel mode. Okay. So you have the open function. Inside it, inside open function, you will have something executed like the system call. The example we were talking about, printf function. When you call printf function here, it switches between the user mode and the kernel mode. So the printf function to be executed inside printf function, you will find the system call write. Okay, so write will be inside printf. So it's like we are wrapping write with printf. We are hiding the system call, we hide the system call write by another name, printf. Why? Because it will make it simpler. Why? Also to protect. We want to protect. We don't want to use a system call. We don't want to access the kernel. Huh? We don't access the kernel without making sure that we write properly without any problems, without any mistakes, without accessing wrong locations. So inside printf, there is some other code is written here to guarantee we make sure everything is okay. Then we use the write. We don't allow the user to write directly. Right? This is why we use a printf and how it is done. Right. Okay. So what types we have in as system calls? So we have process control system calls to create processes, end processes, etc. So we have file management system calls. We have device management system calls. So every service in the operating system, they have system calls related to it. We have information maintenance system calls. We have communication system calls. We have protection system calls. If you go back to this big image here, this one, okay, it's the same. We have system calls for this, system calls for this service, system calls for this, system calls for this, etc., etc., etc. For every one of them, we have specific system calls. Now, what are the system calls you are going to learn? These are the system calls mostly you are going to use in throughout this course. Our most focus will be on the process control. So we have create process. We have in Unix or Linux, you will learn about fork, about exit, wait, open, read, write, for file management, etc. Inshallah, it depends on the lab, but you will learn quite a good number of these system calls, but the focus will be on the process control. So these are the orders or the commands, the functions we are going to learn inshallah ta'ala. Right. This is the example I was talking about in a few minutes ago about printf. Okay, so this is in the user mode. I want to execute printf, and inside printf there is a system called write. So we switch from user mode to kernel mode to execute because we have a system called here called write, and then it is executed. Right. The second part of our class today is about what are the design considerations for an operating system. Okay, so I tried to write here some few questions, which is also very, very important questions. In chapter 2, if you would like to think to design a new operating system, okay, we want to design a new operating system. So first we need to identify what are the goals of this operating system. Okay, what we aim to, what are the points that are we need to focus on. So there are mainly three things we can focus on. We focus on the services that the operating system provide. We focus on the interface that it makes available to users and programs. We focus on the components and their interconnectivity or interconnections. So these are the three considerations or viewpoints where we, upon this, these are the things we consider to design a new operating system. To design an operating system. So again, the services, the interface, the components. Right? So these are the three major things we focus to design a new operating system. So you may have uh, اللهم صل على سيدنا محمد. I will give you some examples of some operating systems currently available. But generally, the goals, why we create an operating system, what are the goals? There are goals for the user goals, and there are system goals. So user goals, like operating system, should be convenient to use. Yani this is ease of use, how easy it is. Easy to learn, reliable, safe, and fast. So these are the things that the user would like to find in an operating system. A system goal would be operating system should be easy to design, implement, maintain, as well as flexible, reliable, error-free, and efficient. So these are the most important goals for any operating system. Uh, Maybe if you would like in the future to work as a software engineer, so these are the things you might work on. You never know. Might, subhanallah, one of you create or be a member in a team to create an operating system. You design and create an operating system. Maybe it will be the first of its kind, and then this operating system might find implementations in the industry. So you don't need to compete with Windows or Linux or Unix. No, you can compete with smaller implementations of the operating system. Maybe operating systems for some uh, manufacturers, uh, small manufacturers. Okay, it might be useful. If you look into smaller operating systems like BSD, or maybe if you look into Android at the beginning, it was small operating system and start growing and become very large. So you can do something like this, very small targeted segment of the market with a small operating system, not big, right? Maybe operating systems for security cameras. Maybe, you never know. طيب, anyhow, when you implement the operating systems, uh, mostly it was assembly language, okay? But nowadays we focus, as I said, in C and C++. طيب, we already said that, خلاص. Okay, now if you look into uh, a general purpose operating system, okay, then there is multiple ways to structure this operating system. So there is a simple structure like MS-DOS, and more complex like Unix, a layered, okay, way to see an operating system abstractions, and microkernel uh, type such as the MASH. This is a MASH is an example, okay. طيب. Now the Unix is monolithic. It means something like homogeneous, or uh, the Unix have Unix limited by hardware functionality. This is the original يعني, Unix when they created it. It has limited structure. Okay, it has two separate parts: the system programs and the kernel. So if you look into Unix, the goal of whoever created the Unix, his goal, he wanted to focus in the design of Unix on system programs, This is his focus. This is his goal focus. Okay. As I mentioned few minutes ago, that when you design an operating system, you have to say, okay, on what would I focus? Okay. So this type of operating system, it focuses on the services, on the services. Also, if you go back here, okay, user goal and a system goal. So this, whoever created Unix, he was not really much caring about making the user friendly graphical things for users. No, he want to make sure that the system goals are fulfilled. So he was focusing on the implementation, maintenance, flexibility, reliability, error free, and efficiency, etc. طيب. So this is an example of how the traditional Unix system structure, okay, how it was simple. So they were talking. There is a shell, which is like a command prompt, okay, and the library is there. System call interface to the kernel. So there was I/O, okay, I/O handling, and then the I/O system disk and tapes drivers. طيب, and CPU scheduling. بس خلاص, it was simple as that. طيب, then the interface to the hardware, to the controllers, for the disks, for the terminals, etc. And some of you maybe don't know what is a terminal. A terminal, it was simple as a small screen, a screen with a keyboard, no brain, no disk, okay, no memory, just a screen and a keyboard, and it is connected to a server, a big server. So you have many monitors and keyboards, monitor and keyboard, but mafi, no memory, no disk, nothing. Everything is operated on the server side, and whatever executed in the server side, it will show on the screen. So it's very old version of Unix, right? And later on, they developed the Linux, not Unix. The one before here is Unix. This is one operating system, old, and this one is newer than Unix, called Linux. Okay, so here they write it system call interface here, and then things get more complicated, where you have CPU scheduler, memory scheduler, character services, block devices, network, and file system. Okay, so they have this type of structure. Okay, uh, we saw this before. This is the layered approach. How do you can see the things? Some operating systems are microkernels. So for them, moves as much from the kernel to the user space. يعني we focus our goal is when we design this operator, we focus on the user. Right? So we have an example of it is Mac OS Darwin, or whatever they call it. So they were focusing, we need the user to be very happy, a very lovely graphical user interface. And this is the originally, if you go back history, you check the history, you find that what make Apple company popular is they were they were pioneers. They were the first who created a very handy, very nice, beautiful colors for the user interface. So they were the pioneers there, and this is where they become very popular. Because if comparing to other operating systems, they were using command prompt, just a very black screen with text. There's no graphics, nothing. Right. Now, what happens if you focus on the user space or on the user interface and user side? So the benefit is when the kernel is smaller, then it's easier for you to extend the micro. Micro they mean a small, يعني a small kernel, يعني easy to extend this micro kernel. It means you can have this small operating system, small kernel for this user, and then another user he might need more features. You can add more features. It depends on what do you need. So you add features to the kernel as necessary, as necessary. Also easier to port the operating system to new architectures. More reliable, more secure because it's يعني small, so you can control it better. But the problem here in the performance because there is an overhead of user space to kernel space. So in the user side there is a huge graphics and a lot of overhead. So it will affect the performance. So this is a structure for what that focus on the user mode. So you have the device drivers, file system, application program. Most of it here, like if you notice, they are run in the user mode. So this we are giving more privilege to the user mode to make his experience using the computer fast, very quick and reliable, and also beautiful in colors. So we've put these things here. And if you remember, if we need to make the user interface beautiful, then the monitor or the display, it has a lot of graphics. So the device driver for the monitor here, it must handle all graphics here. And this is very large memory. So we give it privilege to the user. طيب. So the kernel mode is less services at the kernel. If you notice 1, 2, 3 only. But if you go back here, you see here in Linux we have many services here, 6 services. So we focus on the system, not the user. طيب. طيب. Here we have the concept of hybrid systems. So most common operating systems are not one pure module. So and a module here, they call it the loadable kernel modules. So they use the object-oriented approach. Each core component is separate. Each talks to other over known interfaces. Each is loadable and needed within the kernel. Right? So most of the common operating systems, they divide their services into multiple modules, so it's easy for them to manage. So when we say hybrid, it means we combines multiple approaches to address performance between security usability needs. Okay, so this is a Mac OS and iOS structure. So we have the user experience, UX, the application frameworks, the core frameworks, the kernel environment. So if you notice, where are the services? It's not there in detail. So this is a module, this is a module, and this is a module, this is a module, this is a module. 1, 2, 3, 4, 5. 5 modules. So instead of when you design like this, you put details, you cannot see where is the how things are grouped. In the module design, no, you group things together. You group things together. Okay, you don't give these many boxes. You make it simplified. So this is the simplified, few boxes only. So these are the modules, you know. This is the Darwin also with the mesh kernel. Okay. In iOS, uh, they have also their own way to uh, structure the operating system. Android also, you can take a look in all these kind of different structures of operating systems. You can have as much as you can. طيب, thank you very much for today's class and keep in touch. Inshallah, see you at 10 o'clock at the time of the exam. If you have any queries and questions, write it in the forum. Have a good day. Assalamu alaikum wa rahmatullahi wa barakatuhu.